B. What is the independence number of wheel graph Wn with n plus 1 vertices, where n is greater than or equal to 3. Here 4 options are given, and we have to select the correct option. In order to solve this problem, first of all we need to know what is independence number. Independence number is nothing but the size of the largest independent set, whereas let us write the definition. Independence number, it is the size of the largest independent set. Largest independent set. What is independent set? So let us write the definition for independent set also. Independent set. Set of vertices of which no pair is adjacent. Here one more thing is also there. Here wheel graph is denoted by Wn, and it contains n plus 1. It is given that it contains n plus 1 vertices. There are two notations. Different authors will follow different notations for representing wheel graph. Some authors will follow Wn wheel graph with n vertices. They will say that it contains n vertices, and in that cycle will be of length n minus 1 length cycle. Some authors use n to represent the cycle. In that case, when Wn contains n plus 1 vertices, here cycle n length cycle will be there in this kind of cycle graphs. So here we have used second notation for representing the wheel graph, and we know that just now we wrote down the definitions for independent set and independent number. Independent number, it is the size of the largest independent set, whereas independent set is a set of vertices of which no pair is adjacent. So now let us take W3. So according to this representation, it contains 4 vertices. So let us write that cycle graph with. So this is a cycle graph with 4 vertices, W3, and it is represented by W3. So let us find the here the independent number would be the size of the largest independent set, and here the independent set would be only, at most we can take only one vertex, so that no two vertices are adjacent. If we take more than one vertex, it will be adjacent to this vertex. We can't take this one, or we can't take this one. Why? Because these two are adjacent. We can't take this one. So here vertex number is, independent number would be 1. So if we see option B, it states that n by 2 flooring function, n by 2, 3 by 2 flooring function, will be getting 1.5. Flooring function of 1.5 will be 1. Let us take one more example. Here I am taking W4, which contains 5 vertices. So this is W4 wheel graph with 5 vertices. Now let us calculate what independence number for this graph. So if we, at most we can take see, if I am considering this if I am taking this vertex, I can't take this, I can't take this, I can't take this, I can take this. If I am taking this, I can't take all of this. If I am taking the middle vertex, center vertex, I can't take any other vertex. So here largest will be getting largest independent set as 2. The number of vertices in the largest independent set would be 2, and that is nothing but independence number. So here and if you substitute in option D, it will be 4 by 2 ceiling function, sorry, flooring function, you will be getting 2. So here we can say if you take any other wheel graph with more than 5 vertex, with more than 5 vertices or 6 vertices, we'll be getting this option B would be satisfying. So we can say the independence number of wheel graph with n plus 1 vertices will be flooring function of n by 2. So here correct option is option B. In this question, number of subsets of even cardinality of a set is given as 32, and we have to find the cardinality of the cardinality of that set. That means we have to find the number of elements in that set. If a set contains n elements, let us suppose, let A be the set and the number of elements in set A is nothing but, let us suppose, let it be n, then number of subsets is equal to 2 power n. And number of subsets of even cardinality is equal to number of subsets of odd cardinality is equal to 2 power n minus 1. So here 2 power n minus 1 is given as 32. It implies n is equal to 6. That means number of elements in set A is 6. So here correct option is option C.